Okay. So can I start?
Yes, go ahead.
So I had actually listed down 2 to 3 ideas based on some papers that I went through. So first idea was to add stage development to active inference agents. Like the I could not find a prior work where they have used active inference and stage development, like moving from juvenile to adults. And I did found structural learning papers, but not this type of papers. Also, this was just an enhance, like we can add endogenous transitions rather than uh, moving development through fixed time clocks. And it seems to answer these two questions. The first idea, whether does a phase structured prior schedule produce better generalization than a uniform prior schedule? And does the agent that decides its own transition timing outperform the one on a fixed clock? So these were some of the papers that I went through. Like first one was the foundation paper of active inference. So it talks about uniform updates, but there are no developmental stages within it. Second was beyond the adult mind paper. It's mostly a theoretical paper where they have discussed that predictive processing is a little bit inefficient to account for cognitive development in infants. Like, um, just to explain, they have not told that it's not correct, but uh, in order to explain, we need a complete theory of cognition. Like, we need an agent that starts from nothing to a fully developed model, like how a newborn who starts with no model builds up sophisticated models. The challenge PP mostly describes incremental updating of an existing model, but babies need something far more radical. They need to construct entirely new structures from scratch. So this was the challenge that this paper discusses. The gap was to introduce a flexible starting point and a structural learning toolkit that this paper addresses. Active inference for learning and development in embodied neuromorphic agents. So uh, it's a paper that discusses that in order to show a true intelligence, we need three things: a body, learning through physical interaction with the environment, neuromorphic hardware, brain inspired computing that process information the way neurons do, and a developmental approach like learning that progresses from simple to complex. The fourth paper was emergence of goal-directed behaviors or active inference with self-prior. So this paper proposes how goal-directed behavior emerges in early developmental stages. Like they modeled a child with a sticker on one hand, another. So without any rewards, the child removed the sticker due to mismatch between the internal environment and the external. So the experiment also proved that infants aren't stubbornly fixed forever. If a change persists long enough, the infant's brain will eventually update its baseline. So another addition to the first idea would be to add heterochrony, like to extend and see how different developmental windows affect, like in uh, different stages of life. What if one stage of life is given more amount of time than the other, like something that happens in C elegans as well, I think. Like in larval stages, if one window is much more open, it mutates. So again, I could find some papers on critical periods, but mostly on neural network and not on active inference part. So that gap still remains open. And the third idea would be to extend this paper of goal-based NCA. They have shown that the neural cellular automata is somewhat robust to loss of data. Like if there is a 40% loss of data, it can still uh, somewhat get to the end goal, but there's a gap that what if the data is damaged? Like, can the NCA recover from partial information rather than loss of data? What if the data is damaged? So these were the three ideas that I just shortlisted down. I just wanted to know whether which idea should I go forward with, or are there anything that you suggest?
Hmm. Yeah, this looks pretty interesting. Could you scroll up again?
Yes.
So yeah, I mean, definitely, um, thinking about all these different mechanisms that you could sort of incorporate into the work. So you have, of course, the reason why we want to pursue development. Well, there are actually two reasons, two main reasons. One is that it's not like adulthood. So you usually have like the origins of an adult network or an adult model or something like that. So, like you say, at a development phase like juvenile, brain is more plastic, and we assume that the developmental stage is weak priors versus adults who have strong priors. And then we could add in something like a phase transition or some sort of clock mechanism that would like kind of time out that transition from development to adulthood. So I mean that's kind of one reason we do it. Another reason, of course, we do development is because we're interested in this nature versus nurture question, which is that if we have sort of nothing as the origin of your prior, how do you gain a prior or a strong prior? And the answer to that, of course, is you collect data or you acquire information from the environment. But then there's that process of development. So that's kind of what's interesting there. And then you can, of course, add innate features, which are things that are sort of hard coded, but they're not deterministic long term. Like, they're there to give the sort of maybe the set of priors that's um, you know, just something is like almost like a set of training wheels, where you have things that you inherit, that you start with, tendencies that you move towards, and then plasticity might move you away from them as you learn, that sort of thing. So that's all kind of why we do development. So I think like some of these approaches, like you're kind of going in the active inference direction, which is where they're interested in kind of this sort of gradual improvement using Bayesian methods like priors. They're interested in epistemic uh, aspects of that model, where it's like what does the knowledge look like, um, and then of course you have predictive processing, which is kind of part of active inference, where you have some sort of neural model that can do prediction of things. And processing is a predictive act. So neural processing is about predicting things in the environment. If you encounter things, if you get information from the environment and you acquire it, then if you see something that you've seen before, then you use that to predict maybe the source of food or maybe some other connection that you can exploit. So that's predictive processing, and then this is something that, of course, we can't necessarily use in development because it's inadequately defined as the theory is defined today. I mean, like this area, like of predictive processing, is like hotly debated in the cognitive science literature. So, like, if you were to go in that direction, you'd have to engage with those critiques and the especially in terms of development. Like, you have to really kind of dig into the literature a bit for that, to make sure that we're answering the question that people care about. But this, I think, is a nice question, though. That you have these things in development, or you don't have these things in development that you acquire through development. So, like predictive processing, you don't necessarily see it maybe in early development because you don't have any priors or you have very weak priors. But as you move along, as you gain experience, then you gain predict the ability to do predictive processing, basically. So I mean, this is, and I have to say though, a lot of times people talk about babies and newborns, And it's like, this is very human centric. So there are a lot of other types of developmental systems where, we could draw from as a biologically inspired model to kind of bolster the arguments or gain inspiration for different approaches to this problem. Like, for example, there are a lot of organisms that have a lot of priors that they come with, or I'm sorry, a lot of innates that they come with. And it's a matter of going from sort of innateness to, plasticity coming online. And so that's kind of maybe another way to do this as well. Move down a little bit in the document. So yeah, we have embodiment, of course. We have neuromorphic hardware. Neuromorphic hardware, that's something that is. We can also look at like spiking neural networks and things like that as the software equivalent of that, where you basically are drawing from sort of the hardware of the brain, as it were. I don't like to say it like that, but like it does draw more from this. It has this inspiration of implementing something in hardware rather than just simulating like behavior or simulating a very broad representation of what's going on in the brain. Yeah, I think maybe that's maybe not as sort of central to what we're doing here, or it would be a little bit harder to implement that. Embodiment is a very important part of development, of course. We have, of course, we would like to evolve our agent's phenotype along with the behavior. So if we're talking about acquiring priors in development, you're acquiring priors from the environment, but you're also acquiring it from the phenotype as it's shaping. So as you gain length in your arms, or you gain, the ability to coordinate your arms, or you gain the ability to coordinate your legs, you can start to walk, basically. So, if babies learn how to walk, it's because they have this prior motor circuit that allows them to walk, but they have to coordinate it through learning and plasticity, and so that's what they do. And so that's, the whole process of learning. You learn that prior through some innates and some experience with the body as well as with the environment. So that's kind of how embodiment fits into that. Then you have goal-directed behaviors and active inference. So again, goal-directed behaviors are, I guess you have to sort of start from a non-goal-directed state in your infancy, and then you move towards goal-directed states because you learn what those goals are, or you learn kind of how events kind of move towards an end, at least in cognition. And so that's kind of what this is. I think, yeah, negative feedback. And so Jesse's interested in this area. I mean, he's written some blog posts on that. We've talked about this cybernetics paper where they lay out this taxonomy of different behaviors, which we can talk about. But I think, yeah, I mean, like, I think one of the key things here is just kind of saying, what is development? What does it mean to develop versus be an adult? What does it mean to have a body that, or to kind of grow into an embodiment, or to grow an embodiment from basically nothing, and that sort of thing. So those are all important things. Can you move down a little bit? Yeah, and then so of course, we want to implement this in some agent. We have, we've worked a lot with brain-bird vehicles. We can embody it in a generic agent. I mean, we don't have to embody it in any specific agent. And then there's the NCA, which is the neurocellular automata. I think that's neurocellular automata are interesting, but it's kind of something that is, I don't know how well integrated it is with some of the other questions. I know that, like, they have sensory motor Lenia, which is a software package. Lenia is an approach that was developed by Bert Chan, I believe, at Google. And it was a set of approaches where they have these continuous cellular automata. And I think NCA is actually kind of part of that whole area of inquiry where they're developing cellular automata that kind of fit in with embodied models. Um, there have been some attempts to model development with NCAs, but it's largely like kind of seeing if you can match a template. And so I don't know if you can do really effective developmental modeling of agent behaviors using like NCAs or a sensory motor linear. Well, I know the sensory motor linear they've tried to do development. That was actually the Pierre Audier and his group in Paris. Um, but that's something that maybe we try a more conventional model first. Um, but I think maybe focusing on the active inference components would be good. Um, and then thinking about the difference between development and adulthood, and then getting into some of these other questions. I see you have heterochrony on the list, which is of course the timing of development, and that's of course important for how things are acquired and how long you're exposed to them and how long the embodiment grows, as opposed to, in direct correlation with the exposure of something. Yeah, we've talked about critical periods as well. But the first thing I would do here is to get down this distinction between development and adulthood, and then think about what is it that we're interested in looking at? Are we interested in looking at how maybe some task is acquired? And this is like in how they've used development in AI. I think in the past has largely been as a mechanism for improving training of models. So you're training models by having them acquire data, and then you want them to generalize. You want them to learn associations. You want them to do all these things. But a lot of times, acquiring data is a hard task for a lot of agents or for a lot of algorithms or models. And so it's very hard to train something and get it to work, um, and have this world model sort of there available to it. So the developmental schemes have all been kind of how do we do this more efficiently? Um, but in like computational agents, then we have this additional layer of if you were using a robot, how do you get the robot to learn tasks like sensory motor coordination? Because it's not just as easy as giving it instructions, because it has to work within an embodiment and coordinate everything. And giving instructions is very hard. It has to be able to explore different options and then implement a solution. So I think I think I would start with that distinction between development and adulthood, and then move into some of these other mechanisms, maybe like critical periods and heterochrony. We might also talk about like priors as a general principle for how we make how an agent will sort of formulate a way of doing things. So if you don't have experience with anything, you can't really have strong priors. But once you get experience with things, then you can have strong priors, and it allows you to be more predictive. So those things I think all fit together in a very interesting way. I know that like in terms of finding something novel to do, that the active inference space I think is quite fruitful, because I don't think anyone's really kind of gotten into thinking about active inference and development and what that means for sort of acquiring knowledge or acquiring priors and really working that out. So I think that's actually a very good place to focus on. And active inference is a really hot field, I guess, or has a real strong interest by a lot of people. So Yeah, I think that's a good way to go. Or Jess, would you like to say
Also,
something? Oh,
No, Kava, you can go first.
yeah, no, I was just saying that I also found some recent work where people were combining active inference with LLMs and trying out different things.
yeah. There's a lot of combination of things. Like people are active inference is kind of a framework for understanding. So it's like a theory, but it's not really a theory. That's there's this whole debate of what a theory is, but so it's a framework, I guess, that's predictive. And people will use this in different settings. So if you go to the Active Inference Institute Symposium, you have people applying it to all different areas, like large language models, biology, um, medicine, all sorts of things. And so it's just a matter of figuring out how that fits into what you're interested in. Yeah.
Yeah. Um, to that end, I would say, I guess it's the free energy principle, but sort of the principle versus theory stuff, and the principle has like principles not being able to be disproven, but does it fit the principle or not, kind of a thing like that. That was maybe a useful way to think about some of it, but more so, I wanted to jump in and say um, what I'm have deep, long-standing, and whatnot interest in related to what Kavya's been discussing is um, anything that kind of lends to highlighting, because what basically doubling down a bit on what Bradley said about the difference between development and adulthood, or how uh, I mean, I think one of the most, especially in a human sense, and this is part of mental health paradigms perspective that Joe Pro is part of. It's an inherent part of cognition futures, but not necessarily not. Cognition futures is a bit more broad than like specific applications of, like, we're not talking about the DSM there very much, which is like the manual for mental health evaluations and whatnot. Um, but where I'm going with this is like I am very interested in things that try to look at and demarcate well the ways that different stages of development are, let's say, non-uniform in their capacities. And like we kept talking about, I asked Bradley, oh, what about developmental freedom? Developmental freedom. It's sort of this concept we developed that addresses some of this, or at least tries to offer a lens of the trade-offs between where the progression in someone's developmental process and certain certain things are more flexible, certain things are less flexible, you know, and kind of like the idea of when a small a small animal or a mouse is one of the things I did in an old neuroscience lab a long time ago. Like what when the reason that a baby mouse, or for example, cannot entrain itself and develop a circadian rhythm in the way that an adult mouse can is because the the little of the hardware isn't there yet. Like the hardware has to mature over a couple days so that there can be something that seems like a broader circadian rhythm taking hold in the whole body, right? So it's like there's these different components of when things come online and what kind of regulatory systems actually begin operating at what level and so on and so forth, and what's before, after those states, right? What's sort of the sunsetting of those states, right? And I guess like I'm very interested in things that help to demarcate what those things, what those states, or if Avery was here, macro, not just allostatic kinds, but the allostatic points of these systems as the different regulatory components come in and out of operation across developmental periods, and then yes, in the Bradley sense of difference between maturation and development and adulthood, as a particular, like, a lot of the things that we talk about all the time, we use language of, oh, in precise biological language, like, oh, in the adult human being, or in the adult field mice, or in the adult, insert organism. But in many spaces, and in a lot of common, especially human side of things, we don't always have much. A lot of our models and perspectives are quite shorthanded to very long-standing issues that all people and brain, everything, everything is referred to a very particular model of what a person's experience is. So things that bring nuance to what that is. And yes, I'll go. I don't like going here in a critical theory or ethics component, but yes, the many models are basically built off of the middle-aged white man as the point of reference for many models, or health, or normativity, or standards. So that's like one branch of it. But even beyond that, like, sociological component, just bringing the nuance into the developmental states, I think, is something that I'm very interested in at large. So I'm glad that you were putting this together. Like, I don't know what next steps you have in mind, Kavya. Bradley's pointed out some things. There's a fairly rich history in the lab of stuff that you can point out, or that we can point to. And I'm definitely excited to see where you go with this. I think I kind of wish Ashu was here, because I know Ashley was talking about this, and I don't think she was at the last meeting either. So I wonder if she would be interested in that as well. And they might have some other folks from across the lab, or in JoPro, that are there may be more interest here than it seems, because you're the only person bringing it up in the meeting right now. But I would say, like, you could find you could find some folks that are interested in this if you want to continue to develop it out. And not saying they all have to work with you or be teammates or whatever, but people who are willing to talk to you about this, they are here, even if they're not in this meeting right now. So that's my 2 cents.
Yeah, thank you, Kavya. It was very good. We'll keep working on this and working through it. Let me know, like, what your thoughts are, like, offline about this. Yeah, I think it's definitely, like, there's something there we can focus on, and maybe there's more than one thing to focus on. But I think probably, like I said, there's a kernel that we can start with, and just focusing it down to, like, some implementation. Yeah.
So, just one thing I wanted to ask. So, should I just start with this first idea, like you mentioned that development, maturation, and differencing that out, and just starting with some implementation of it?
Yeah, so get a good idea conceptually of how you want to approach that, and then you can implement it in Python if you want, just a demo, and then we can review the demo and see how it works, see what the performance looks like, and then refine it, because you can't really start unless you have a good base.
Yes.
All right. Yeah. Thank you.
No, thank you so much.
Yeah.